Alright, so my name is Thomas. I'm going to talk to you about scaling AI adoption from 30 engineers to tech-wide transformation. So first of all, who am I? So I'm an AI platform product manager at Doctolib. So Doctolib, I think you all know what it is, but if you don't, so it's an online booking platform for patients to book their appointments with their practitioners, and we are present in all Europe. So I'm going to talk to you about how we managed to have the scale of starting with 30 engineers to have 600 engineers in the end using AI tooling. But just a few numbers as to where we are right now. So as I mentioned, Doctolib has 600 engineers. We do have, at the moment, 60% of them who are daily active users of AI tools. So we do leverage those tools very much. And those tools are Cloud Code, Cursor, and GitHub Copilot. And if we zoom out a bit in terms of weekly active users, we are at 75% to 80%. So we are very much invested into using AI into our tech. How it started, so back in May, we had a single pilot phase with 30 engineers. It came from an action that was both proactive and reactive because both our leadership team was very interested in basically achieving productivity gain thanks to the AI tools, and as well as a proactive reaction because some of our engineers were had already started using AI on their end, which created a kind of a shadow IT inside the team, which was not something that we wanted to have. I'm skipping the pilot phase, but after the pilot phase, landing for a month, we had like pretty positive feedback from the 30 engineers. So we decided to expand the pilot and start the beginning of Q3, so beginning of June, to have all our engineers leveraging those tools. So we gave them a license for all those tools and starting the experiment with them as a global experiment for the whole tech company during the quarter. So Q3, we are joining it with having a single goal, having all of them use AI on a daily basis, basically. Adoption, that's our main focus and the focus we've had during this whole quarter. And why? Because as of right now, agentic coding is still relatively new, and we're still discovering use cases on a daily basis, on a weekly basis. And we wanted to highlight the experimentation and learning all together first, so that we later on could basically scale and maximize the impact of those AI tools. Just a quick note before I deep dive into the presentation. So, as I mentioned, I'm a platform product manager working on tech topics. So, as a first approach to try to increase the adoption, we basically treat our engineers as a first-class customer, and it means that we have interviewed them a lot, hearing their complaints, hearing their pain points. And what I'm about to share to you tonight is the first and major pain point of adoption in our engineering team among the 600 engineers. And that's what I'm going to present to you, and different actions that we took to basically try to have them become adopters. So the first friction point. The friction point was about quality and reliability. And basically, the engineers were afraid that the code generated by those tools would be basically poor, so it would be bad code and something that was not going to be shipped into production. And sometimes they even felt that the output of those LLMs through the AI tools, the Cloud Code, etc., were not really actionable. So to address those, a few actions were taken. The first one was making sure that, first of all the new joiners at Doctolib would get a proper training at first while joining the company, so they can get up to speed with our recommendation. and the recommendation, we basically created a whole documentation space for them, which has a ton of different information in terms of best practices. So, how do I use Cloud Code, Cursor, whatever, to write unit tests? How do I use those for creating documentation? How could I migrate React Query v4 to v5, for example? Like a set of guidelines and best practices, but also pitfalls, like the psychopathy of LLMs, for example, like the LLMs being too kind every time to the engineers. So we try to highlight those and to have like a proper documentation space that they can consult and they can act on. Second friction point was the lack of confidence or knowledge, basically. So I have a new tool. I have access to 3 new tools actually. What should I do with them, basically? So there was first a low confidence in usage. It was difficult for them to determine how they would apply the LLM magic, let's say, to our code base. And there was also like in the end like a poor awareness of the already existing use cases that some engineers already found and developed along the way. So a few actions there. First of all, we created what we call an AI camp, which was like a week of trainings for the whole engineering team during the summer at the beginning of July. And one of the few sessions during the AI camp were basically one-on-one hands-on session where senior software engineers would basically do some hands-on session with all engineers, like in closed groups, like 10 to 15 people, and have them use and have them set up those tools correctly. On top of this, and to highlight the different use cases and the success stories inside the company, we created a weekly digest, like a Slack message, an email, like on different channels of communication, a weekly digest where we would highlight and share the success stories of specific teams to all other teams, so that we make sure that the learning of some were used by others. Going on to the third friction point, talking about job security and ideological barrier, which was a very heavy topic at the beginning. So basically being afraid of being replaced by a machine, if I may say. And the gist of the ideological resistance towards having a machine writing code. So to actually address those, 2 key actions were taken. During the AI camp, once again, we invited someone from Google, Guillaume Laforge, who actually presents what LLMs are and how do they work, what is a token, how do LLMs work with token, and it basically gave a gist of, okay, it's not magic, there's actually tech behind it, and it demystified like the LLMs in general, and it helped all software engineers understand better what they were working with. And also, to address this fear of replacement by AI, we wrote a vision document, which we called the AI Augmented Engineer Vision, which is a document describing how we believe at Doctolib AI should be used and how it should power engineers and not replace them. Because in the end, we believe that there is a strong opportunity to leverage those and that it will basically enhance the development of all engineers. And it's the next milestone in the tech industry that we need to embrace. And we wrote this document, and it was co-written with our CTO, and it was also shared during the camp that I mentioned. Going on to the fourth friction point, the cost and environmental concern, which was a huge one as well. The underlying concerns were, well, I might use those, but how am I going to impact the company in terms of cost? Because if you are using some models, for example, Opus on Cloud Code, which is very expensive in terms of million per token, in terms of dollar per million token, you could indeed create a huge bill at the end. And the second one was like the ecological impact. Like using LLMs would require computational power inside data center, which would, in the end, create carbon footprint. So to address the first one, in terms of cost, we had a backup of our leadership team to emphasize the thing that we wanted the whole tech organization at Doctolib to actually experiment, discover, learn new use cases, share those with others, and try to build upon those learnings. And the second one was about the ecological impact. It's about actually, it's not the most easiest one to answer because there is no real big papers available yet on the carbon footprint emitted by those LLMs. But we are trying to like contextualize the usage of those LLMs inside the global scheme of everything. Like if an LLM allows you, for example, to save like let's say a few hours of work because it created code for you, maybe it saved you a bit of electricity as well and such. But this is not something really easy to measure. So we're trying also other alternatives. For example, the local usage of LLMs, like having Oleama and such, to have actually run some local models. Like recently, like OpenAI released GPT OSS with 20 billion parameters, which is great to actually work in local. So we're trying to leverage those on specific use cases and limiting the LLM usage running into data centers. And the fifth friction point was about ethical barriers. Okay, I'm having trouble getting a license on Cloud Code or Cursor, and also like the lack of time. Like, hey, yes, you're asking me to experiment, but I don't have time. I have a roadmap to follow, and I have projects and deadlines with them. To address those, we made sure to have a clear onboarding funnel with a recommendation. Like some software engineers were more inclined to have like a CLI approach, like using Neotheme, for example, but some others were leveraging JetBrains IDE, for example, which are very heavy. So we made sure that based on their current usage of their IDE, we were proposing the right tools for them. And we made sure that to have like a proper map and for them in our documentation so that they can follow this map and request the proper tool. And the last one, the lack of time, we made sure that they would not lack any time to experiment because every engineer at Doctolib is actually having personal objective every quarter. And we requested every engineering manager at Doctolib to set personal objective of their engineers to have like 10 to 20% of their time spent purely on experimenting with one of those tools and reporting their feedback, basically. So we made sure that it was included in their time. So that was about the main friction points, but where is our current focus? So as I mentioned, first was adoption. Now we're trying to maximize the impact and measuring the impact as well. Because there's one thing that I like to say is like, if we are producing twice as many pull requests compared to 3 months ago, it means that we double our productivity, right? Well, no, because we might as well have doubled the number of bugs as well, for example. So yeah, doubling the number of pull requests alone doesn't mean anything. So we are trying to have like an understanding of like our engineering inputs, like for example, the number of PRs, the number of line of code, some of the DORA metrics as well, like the deployment frequency, the lead time to change, but as well looking at those with a set of control KPIs, like how many bugs did we introduce this week, how many incidents we created, how's our change failure rate, for example. So that was our first and initial thinking of how we were going to measure the impact. After this, we realized during the summer that industry was basically evolving on this very topic, and this is not like a paid promotion or whatsoever, but we found a framework made by a company called DX, which proposes actually a three-layer framework to actually measure the productivity increase or not from AI tools. And it's decomposed into 3 different layers. The first related to adoption, the second one is about direct AI impact metrics, and the third one is about how it impacted your business. I recommend you to actually check them out. It's pretty interesting. So that's our current focus, but what's coming next? Well, in the end, we found that our initiatives and all our tasks that are meant toward AI tooling adoption was very much focused on the coding part itself. But it means that as of right now, we are actually producing more pull requests. So actually producing more pull requests, produces as well like an increase of pull request review. So engineers are asked to review more PR on a daily basis. It also creates a new bottleneck where if we are producing more in terms of just engineering output, it means that stories might also become a bottleneck because the stories are taken more rapidly. And it also puts other bottlenecks like on the deployment processes of everything, because it means that if we are producing more PRs, we could deploy more frequently, so we need more robust process on those. And just to provide a quick feedback of what we discovered is that just by putting our efforts toward coding, well, in the end, it resulted in other bottlenecks that we are still discovering as of today. And we are globally thinking on how do we approach those AI tools and how do we have like an AI culture in general, so that we can answer all those new bottlenecks that are emerging in the software development lifecycle. That's it.
Questions?
I don't think I have the other mic, so.
It's really interesting what you've done. It's a bit crazy. Last time I came to one of these things, we were talking about how cool these things could be, and now Doctolib has got 600 users. You, out of all those stats, the one that really jumps out to me as interesting is lead time to, I forgot what it is now, sorry, but from idea to delivery.
Yeah.
I was wondering, if you, you agree that that one's interesting, or that there's another one that's particularly interesting to you, or whether it's too early to tell as well. Just I don't want to put you on the spot too much about.
Yeah, that works. Well, looking at DORA metrics in general, I would say it's a great thing because it's like standard of the industry. I won't be able yet to tell you how it impacted us because we are in the very making or actually applying those frameworks to our own metrics, to our own feedback. So I couldn't tell you, but definitely I would say like have a look at DORA metrics and industry becoming standards. I would say like the X, for example. It would give you an idea of where you're going, at least is going in the right direction or not, but so far it's a bit too early for us. I'm sorry. Any other question?
One more and then we'll switch.
Thank you for the great talk. One part that got me interested, you said that you were adopting or even like you were interviewing developers, what kind of tools they were using, heavy and unheavy. I personally have seen on myself, but also with others, that people are tending to use more and more lightweight developer frameworks.
Mm-hmm.
With something like Claude Code or something in the back that kind of like shifts more to lightweight. And I was wondering if you've seen something similar of folks transitioning from big IDEs to more lightweight Neowins or code or cursors.
In terms of tooling usage, I would say yes, like for example, at the beginning, the leading tool in terms of adoption was Cursor, a fork of VS Code. And over time, the leading AI tool nowadays is Cloud Code, and most of our engineers are nowadays users of Cloud Code. And if they are still using Cursor, they might as well have like a Cloud Code license in the end. But in terms of pure ID, we still have a heavy user base of JetBrains ID, for example, mostly because it's tied to their languages that they are writing, like Java-based application, Kotlin, and such. And we did not have yet a decrease of those licenses.
Thanks.